this video, I'll be covering some of the fundamentals behind curve modeling. So I'm going to start with placing some points in Rhino, and we'll be essentially working in two-dimensional to understand the logic behind the curves. So the first thing I'm going to do is, if we want to draw a curve to these points, we can actually do that using the polyline comment. So if I click on the polyline, select these inputs, I can actually get straight lines going through these points. Now, if we want to do that with the control point curve and input the same information, you can see that although the input is exactly the same, the curve actually topologically looks a lot different. So its shape is actually distorted by how we interpolate through these points. So the difference between these two curves is actually really simple. If you want to see more information about these, you can select either one of them and type in the rebuild command. So when I type in rebuild, you can see in parentheses the existing information of this curve. So right now this has 5 control points, and it's the first degree curve because it's connecting the points in linear fashion. Now if I select the other one and type up rebuild again, you can see that the point counts is exactly the same. But the degree is a third degree because we are actually using a quadratic function to interpolate to these points. So I'm not going to go into the mathematical details of that, but just know that the difference between these two curves is actually the decrease. So this one does linear interpolation, this one does an interpolation using a quadratic function. Now what do you think happens when I switch this to number 2? So what does it mean if a curve has a second degree? So I'm going to take the polyline on the left, and then I'm going to rebuild that with the same point count, but to a second degree. So you will see that the input is used to construct these arches. So essentially what we are looking at is how the data moves from linear fashion to a plane to 3 dimensions. So in the polyline, the data is actually linearly interpolated between these points. In the second degree curve, this is actually constructed out of arches. Oh, if I explode this curve, you can see that it's made out of 3 arch segments, and this actually shows you the main property of this curve. It's actually made out of arches that have consistent curvature. So from this point, the starting point to the end of this arch, the radius of this arch is exactly the same. So that means the curvature is exactly the same. So by adding 3 different arches, we can reconstruct this curve. And in the last one is a third degree curve, which means in this case, we are looking at a 3-dimensional interpolation. So we are using a quadratic function. So that is essentially the difference between these curves. So if I were to draw a straight line again, that would be a 1-dimensional curve. If I draw an arc, let's say in this case something like this, this is the second degree curve. Because the arches are constrained to a plane, they exist on a plane. And anything that has at least 3 or 4 control vertices, that will be a Nurbs curve, and learning how to manipulate these control points is really important. And essentially we will be looking at how to control the shape more efficiently in later videos.